So let us talk about energy and chemical and physical changes. Oftentimes when we have a chemical and a physical change, it also results in an energy change as well, which is actually what we're really interested in, as in when gasoline combusts in an engine, it gives off energy, and so that energy is used to power our cars. And we know that like chemical substances like gasoline have high potential energy and they're very unstable. And just like everything else in nature, chemical energy wants to achieve the lowest state possible. So we have something like an exothermic reaction in which the chemical reaction ends up releasing energy into the environment, like gasoline or TNT, trinitrotoluene. So you see that you end up with, if you draw a graph of it, of energy versus reaction time, you will notice that an exothermic reaction will start at a very high potential energy, and then it just needs a little bit of an activation energy, like a spark per se, and then when it explodes, it goes to its lowest energy state possible, so it released all its pressure. But it does need a little bit of an activation energy. We have other reactions, on the other hand, that are endothermic. And endothermic reactions actually absorb energy from their environment. So on our graph, they actually start with low energy state, but then they start to absorb energy from the environment and they react. And this is, the activation energy is much higher. And so we end up with an energy level here higher than what we started with here. And again, endothermic reactions absorb energy from the environment. So let us see how this relates to some chemical processes that we know of. So identify each change as endothermic or exothermic. When we have wood burning in a fire, what happens? Whenever usually you see the word burning, combustion, explosion, it generally means it's an exothermic reaction, that it's releasing energy into the environment. And that is why we end up getting warm from being around a wood fire, because we're taking in all the energy that the actual process of burning the wood is letting out. So always think energy emitting energy into the environment is exothermic, and absorbing energy from the environment is endothermic. So when we have ice melting, what's happening? In order for ice to melt, what's going to happen? Like, let's say that you had ice in a glass of water. What is it doing? It's absorbing all the heat from the water, right? And making your water colder. But the ice actually ends up melting because it's getting warmer. So the ice is absorbing water, or absorbing heat from the water. So since it's absorbing, that means it's endothermic. And so this is exothermic. Okay. Now I want you to try this on your own and replay the video to see if you got the correct answer. So again, we have water freezing into ice this time. Well, what's happening when water is freezing into ice? It's going to let out some of its energy so that it can get colder. So what's happening? If we have water, it's going to emit some of its energy to go into the ice stage. So here this is hotter and this is colder. So that's indicating that heat is being given off. So it's an exothermic process. And again, we see natural gas burning. When something burns, it generally is an exothermic process and it gives off energy. When we have natural gas burning, we use that to heat our stoves and all that stuff. So when natural gas burns, it emits energy into the environment. So it's an exothermic process. So remember, absorb energy is endothermic, and emit energy is exothermic.